distinguished panel members, eminent members of the aerospace community, august audience, ladies and gentlemen. Good afternoon, everyone. It has been recognized that the future air power will be based on a network of intelligent, connected platforms, navigating autonomously and performing missions using highly accurate and real-time information. In modern airborne vehicles, the technology has become more refined and demonstrated an ability to carry out various critical tasks autonomously. Considering the importance of autonomous technologies as part of the DEF Expo 2022 seminar series, Hindustan Aeronautics Limited, the pioneer in aerospace technology development and adoption, has organized a seminar on futuristic autonomous technologies for air dominance. We have invited distinguished speakers representing industry, customer, and academia to get their perspectives and viewpoints on the progress and potential of autonomous technologies to derive air dominance. So this session is divided into two parts. In the first part, each of the four speakers will be introduced briefly and then requested to share his perspectives and insights for about 15 minutes. On completion of the task by the four speakers representing different gamuts of the theme, after an hour, the forum will be open for a Q&A session. Now we shall move forward with the first part of the session. Defense customers are considered as very important stakeholders as they provide inputs on the changing requirements of aero defense in the country and the need for autonomous combat systems, capabilities, and applications. As a customer representative, we have with us AVM George Thomas. I would like to introduce sir to the group. Air Vice Marshal George Thomas, Ati Vishishta Seva Medal, Vayu Sena Medal, is the Assistant Chief of the Air Staff Plans. He is an alumnus of the National Defence Academy, National Defence College, and the UK Staff College. The Air Vice Marshal is a fighter pilot with over 4,200 hours of flying experience on Sukhoi 30, MiG-29, MiG-21, Tejas, and Mirage 2000 aircraft. He is a qualified flying instructor and an experimental test pilot with experience in prototype testing. He has been chief test pilot at both ASTE and NFTC and ACAS projects at Air Headquarters. Sir, now I request you to share your perspectives on the topic, please.
Thank you, Dr. Bharti. Good afternoon, ladies and gentlemen. It gives me immense pleasure to be here in this gathering. I notice a virtual galaxy of the who's who of HAL is here with us, which is very heartening for me, as well as our other distinguished guests. I will talk briefly on the Air Force perspective on the topic today. So before I start, or as I start, I think we need to look carefully at the definitions of what we are talking about, because some of these words mean many things to many people. We'll start with air dominance. Air dominance is commonly understood as total control of the air for an extended period. So to put that in perspective, the US DoD commissioned a study which finally reported in December 2016 on the path to achieve and maintain air dominance up to the year 2035. It's a long study, but the net output of that was that the US government decided maintaining and achieving air dominance was unaffordable. Instead, they suggested the US Air Force go down a path of what they called on-demand air superiority, which means control of the air for a limited time over a limited area to achieve a certain task or output. Clearly, if the US government finds something too unaffordable, and that to the US DoD, so we need to think carefully about whether we can achieve it or not. I'll leave you with that thought. Autonomous, again, falls in a basket of words which include things like big data, AI, machine learning, words which are often casually thrown around. So I cannot actually aspire to, get into the real scientific definition of any of these, but I will look at our perspective. What do we mean by autonomous in terms of the framework in which we are looking at it, which is air control, let's say. I would look at an autonomous system as one which can operate in an uncertain environment or a changing environment without human intervention. Carries out missions, tasks, and roles without human intervention. Automated systems, however, are ones which, in a defined environment, carry out a defined task either with pre-programming or with limited on-scene programming, which once again may or may not require human intervention. Of the latter, we have several examples. I'm not sure that in the domain we are talking about today, we have a truly autonomous vehicle. Also to keep in mind, when we talk about autonomous vehicles in the domain in which I am responsible for providing support in, is we seriously need to think about many aspects, not least of which is the ethical one. Are we in a position politically as a nation to take a decision to leave the decision of executing a combat task which might result in human deaths to a machine? We are not there yet, that's for sure. How we will reach there, we will have to look at carefully. So basically, once we understand where we are in these two domains, I will move on with the Air Force perspective on autonomous solutions in general, which may or may not be hardware, may or may not be kinetic, and take a look at the various aspects. Before I start on that, there is one topic which continues to come over and over again. It is asked several times about, are we willing to replace the fighter pilot today in the cockpit? It's an important question. Very often, we in the Air Force in blue, I'm sure ex-fighter pilots like Samir on the panel will also agree, we are often accused of saying the answer is no at this point because we want to retain our jobs. But that is actually not true. The domain in which a manned combat aircraft operates today has so many variables, and the environment is so uncertain and so fast changing that I believe we are not yet at that point where we are able to merge the number of multiple subroutines which are required to make a whole, which is the fighter pilot, and effectively execute tasks across the flexible spectrum that is there for combat air operations. We are not there today. Will it come in the future? Undoubtedly. Why do I then insist that we continue to retain manned cockpits? The reason is, if I had a choice today and I could replace a human with an entity which goes and operates and I put nobody in harm's way, it is the best solution, ideal for me. I do not want to send somebody where I don't have to. But it is not possible at this point. In fact, yesterday, there was another seminar in which Group Captain H.V. Thakur from HAL was speaking. And I would like to quote him because he said something very good about where we are in these unmanned combat systems today. So he said the current state of the art, and I paraphrase, is that it walks a bit, it flies a bit, and it shoots when you tell it to. I thought that was a great quote, and it's very right. So they are able to operate, they can fly, under control, under command, they are able to even drop weapons. But right now, that is the state of the art. It is not yet autonomous in the sense that we understand it. So does that mean that we in the IAF are not looking at autonomous platforms, not looking at air dominance? No, we certainly are. But what is our path? We have come to realize that dominance in the domain in which I am, in air combat, need not be purely platform dependent, need not be purely kinetic. It is multi-domain. It is across every single domain. And in order to gain an advantage and maintain that advantage over your adversary, you have to be ahead of the drag curve for that. Again, it sounds easy in theory. Be ahead, invest in all the emerging technologies, support. That's correct. But how do you place an order on something that has not yet fructified into a product? How much do you take out of your very, very limited and very hard-earned budget into investing for the future at the cost of capability today? We have a clear-cut job to do today. We have a limited amount of money to do that job. So the balance between investing in a technology which is not mature and building capacity and capability on your current level is a difficult balance which we are walking every day. So let me look very quickly at the domains in which we can operate in let's say, an autonomous... oh, I don't have a slide. Thank you. Yeah, I'm sorry. So if we look at the various domains, we will come to the most exciting and the normal talked about one, which is the kinetic domain. So are we doing nothing at all in the kinetic domain? No, we are. Even if you look at a basic UAV, it has a certain level of automation. It has some amount of autonomy in that it takes care of some of the tasks which a normal pilot would do. Today, we are definitely getting into weaponized UAVs, and we are also getting into teaming, which I'm very happy to say we are doing in conjunction. We are actually supporting HAL's effort in the MUMT, in the CATS program. We are watching it very closely. And we are, shall I say, on the threshold of getting more involved in that as it continues to fructify and we see platforms, flying. As the technology develops, the level of interest increases, the level of participation increases, and it has a snowball effect, which we hope to see very soon. We also are looking closely at long-range strike vectors, which are unmanned, not necessarily ballistic. The debate, again, is about ballistic weapons versus flying platforms. Today, nothing can replace the flexibility, speed of reaction, and reach of a conventional winged platform in a conventional war scenario. Just to put it in perspective now, if we look at air dominance from a manned platform, if we think a little out of the box, it need not be a fighter. If you go by the definition of air dominance, I can take a very large platform, enough engine power to really give me excess electrical power, have a working, successful directed energy weapon, and automatically with that, with the speed of response, the sort of unlimited recharge capability, I will be able to assure air dominance in a certain area. So we are aware of the fact that we need not fixate on a fighter mindset. We need to look at solutions, whether kinetic, weapon-fired, directed energy, whichever way it is, to ensure air dominance over an airspace. The easier, or let's say the more doable option is the assist option. MUMT is one of those where somebody assists you in your basic task in a fighter cockpit. We look at loyal wingman. We look at pilot assistance in the cockpit. We are looking at AI to help pilots, and hopefully in a short while, we will be able to retire our fleet of navigators. WSOs will become redundant in a while. As that technology matures, I think we will see that happen. There is also a support element. We look at autonomous is a good use case for refuelers, for example. The US Navy has already proven it. We would like to see an autonomous medium to large size aeroplane being a refueler in a high-risk area where I do not have to risk human lives on a vulnerable platform. The Air Force has set up a unit by the name of UDAN. It stands for Unit for Digitization, for AI, Automation, and Application Networking. If you notice, even in the name, we have made this distinction between AI and automation. UDAN is the spearhead of our entire AI effort. It takes it forward. We have recognized that this is the way to go. And the solutions we have are across many domains. I'll touch upon a couple of them. We are, the basic idea of creating a center of excellence for AI in UDAN is that we recognize that for true AI at the levels or the scale we are talking about, you need a couple of things. You need very large compute power. You need very large data handling with speed. You will be able to handle, you need a massive data lake. You need to be able to churn that data quickly. And we are also in a process of creating AI subroutines which can be used by various applications across the Air Force. Some of them I will talk about, and maybe we can discuss in Q&A or later. So on the ops side right now, we have 2 or 3 programs already running. Clearly, ISR and intelligence handling is a very easy candidate for this. The amount of data which is gathered today from SIGINT, from video, from ISR in general, photos, everything is huge. If you are to take it and get out actionable intelligence in the time frame which is required to manage a campaign, it needs either a large number of people or it is just not possible to do. We have applied AI on this frame, merged all inputs from various agencies, given them weightages, allowed the AI to understand the context in which we want the output, and the initial results are very encouraging. From terabytes of data, we are able to give 10 or 12 key inputs to the commander to ensure him to carry out the campaign plan. We are working very hard on this, and I'm sure it will continue to give us better results as it improves through self-learning in the future. We also have several modules, about 3 modules, one of which we are doing in conjunction with Bell on our ISCCS platform. We have automated the applied AI rather to intercept solutions, to weapon matching. We are doing multi-sensor fusion to get the best track output possible, and doing something called threat estimation, which is very interesting. When you have somebody across the border, we have found that if we merge inputs like track performance, we merge inputs like voice pickup through comment, we are able to judge with fair degree of accuracy whether hostile intent is imminent or not. Very useful for deciding whether a certain group of targets is a feint or is it an actual attack. Again, the results are extremely promising in this domain. Campaign planning tool we have already introduced into the Air Force for our large-scale planning. But we have another very interesting AI-based tool added onto that, which gives us a measure of what is called ops stamina. To explain this very briefly, if we launch a mission, what we call a COAP, a large package, it's about 100 plus aeroplanes of various types. They go across, create effect, come back. In the old days, we would look for results from that, plan the next. It takes hours, if not over a day. Today, what's happening is the AI is able to understand which targets have been struck. In the background, he's looking at your own bases. He figures out which fuel is where the weather is bad, what is happening with support services, is the tanker available, and he's able to reroute the aeroplanes back to suitable bases, ensure that the weapons are available to be loaded, ensure that there's adequate fuel, support services, maintenance is being done on the aeroplane so that you can churn and get back. As the wave lands, the pilots have the orders for the next wave. Everybody has disseminated the required information as to send the aeroplanes back, and we churn in a hurry. Again, very interesting and very good results from this. We have also got several small applications like airlift optimization. We have the entire transport fleet of the aeroplane, of the Air Force getting airborne in order to support our squadron's movement over a very short period of time. Earlier, it used to be several wing commanders with huge sheets trying to work out which transport aircraft goes where, what does it pick up, how does it go further. And you always had people waiting on tarmac, or the squadron is ferried, their support doesn't fetch up because it's extremely complex. Today, with one AI module, real time, they are able to figure out what's going on with which aircraft, cross-command, cross-sector. Best aircraft is optimized, sent to the nearest base. Nobody waits for more than half an hour. All our movements are optimized extremely well. It's able to pick up, we realized why AI works in this scenario is it is able to pick up changes from planned routing and understand, for example, there is a weather event there is an airspace closure here. Hence, he will not use this aeroplane. They're doing it on their own. We just sit and get the output and use it. It's working beautifully. We also use AI to some extent in weather forecasting, predictive maintenance. Rather than wait for an event to occur, we now look at, for example, the Su-30 as a 1 GB data recorder. We dump them all on a common jukebox. We look at them across time. We look at them across the fleet. You're able to identify trends like oil pressure is rising in a certain aeroplane. It's still within limits. We know that if we let it carry on for some time, you're going to have a gearbox failure. Pick it up before that. Change it. Things like that are working very well for us. Interestingly, we use it cross-fleet. So across the entire fleet, if we find on some day there is an increase in oil pressure in general, we are able to track it back to a different grade of oil which we've got, which is causing a certain amount of, slight lubrication change, causes parameters changes. This is going to be a game changer for the entire maintenance branch of the Air Force once it kicks in across all fleets. We are also using it very, very successfully now for inventory management. Inventory across the Air Force, several fleets. We have Western, Eastern origin aeroplanes now, of course, with the Tejas, with the LCH. We have a large number of indigenous platforms being inducted. Maintaining our inventory used to be, or is still, a very, very difficult task. To help our logisticians, we have now come up with a very, very comprehensive AI tool on the EMOLS stack, which interfaces also with our integrated maintenance management system, which is able to pick up required spares, get them transferred through the transport network so that the aircraft downtime is minimized. In IT, in IW, we have done a lot of predictive, network endpoint behavior. We're looking at code compilation screening for all the code we are writing so that it's not done manually. And we have certain ADAM applications as well in, base defense solutions. But coming back to that again now, how do you take that decision? If you have a remote weapon station on the perimeter of a base and the AI decides that there is suspicious behavior, can we clear him to open fire? We cannot. We cannot let a machine or a weapon open fire by itself. So we come back to the same issue of how do we use AI in combat platforms? It's difficult. I think I'll summarize here by just saying that the concept of using autonomy in air dominance is not restricted mainly to just platforms. It is across the domain, across the piece. We need to see how to integrate it to speeden up our reaction loop, our reaction cycles, and become more effective as an Air Force. I'll be happy to take on questions later in the session. I'd now like to thank you, ma'am.
Thank you, sir. Thank you for sharing your practical perspectives about autonomous technologies, what it means to the customer. And also thank you for sharing on the various initiatives taken by the customer, the game changer aspects, and also extensive usage of AI to manage your inventory and other aspects. Thank you very much. Now let us try to understand about HAL's efforts and capabilities in the field of combat autonomous systems. Now I invite Shri S. Krishnakumar, Executive Director, HAL ARDC, who is a core member of the LCA Electrical Design and Integration team. He has been awarded the Swarna Jayanti Award for the year 2000 by Aeronautical Society of India for his contribution to the design and development of LCA. He is now heading various indigenous design and development activities in manned and unmanned aircraft platforms, including next generation fighters, combat air teaming systems, UAV, and trainers. Sir, please.
Not there. They put in percentage. Good afternoon, everybody. See, I've also covered most of the things have been what was talked by my friend AVM George Thomas, because most of the dissemination, whatever I tried to disseminate, I think he has also disseminated in the same way this topic. There's no percentage. There's nothing. Okay, because I didn't make notes, I made a presentation for the whole thing. Okay. It's not coming. Oh, there he is put. No. This is professors. Yeah. Okay. Okay. So what is air dominance? This is exactly what my friend AVM George Thomas said. Air dominance or air supremacy is the degree of air superiority wherein the opposing air force is incapable of effective interference. Okay. Now, it is the situation where one force holds the complete control over air warfare and air power over the enemy air force. Coming to air dominance, the game changer technologies basically are the stealth or low observability, the payload and range, what you can get, AI and autonomy, self-healing structures, high speed and maneuverability, and highly lethal and accurate weapons. This topics what I have covered in my approach to the futuristic autonomous air systems is AI-enabled sensors and systems, complex battlefield operations, what it requires, enhanced avionics and mission sensors, sensor fusion, wearable cockpit, which is an interesting topic, directed energy weapons, hypersonic weapons, self-healing structures, nanomaterials, that is stealth and camouflage, and other areas of ongoing research, futuristic. Artificial intelligence is, as George Thomas said, a move from automation to autonomy. High incorporation of AI into avionics suits through high-speed connectivity to data links with entities in the airspace and on the surface. This defines the AI-enabled sensors and systems. It's a move from automation to autonomy in flight. AVM George Thomas raised a question whether we are ready for full automation. In early 2000s, one of the current CNC of SWAC had a cartoon on his table which said that this is the future cockpit of the aircraft. It had a pilot and a dog, and the statement was the job of the pilot is to feed the dog, and the job of the dog is to see that the pilot doesn't touch anything. That's where autonomy is. Automation, as he brought out, was nothing but automating whatever we were doing without our intervention. Autonomy is something where decisions have to be taken in terms of crisis, not only in terms of crisis, when failures happen. When you plan an activity, in between the activity, if there is a failure, there has to be a decision taken. Today, the decider is man. When it comes to autonomy, it is the machine or the system which is going to decide what is to be done. AI-enabled avionics, that is, will perform intricate tasks in complex environment without the need for human intervention. Aircraft designs under development are increasingly leaning towards optionally manned versions. So when called for, you can have the pilot. When it is a dangerous situation, when it is a threat, you won't have the pilot, but it will be doing the mission on its own or autonomously. AI-enabled sensors, if you can just list out autonomous target detection and recognition. On this, we at HAL are working on a big scale with IIT Kharagpur, and autonomous ISR, as AVM George Thomas brought out, the intelligence, surveillance, and reconnaissance, the amount of data that you get from the various satellites, sensors, or name it all, is so huge that to pick out what you need from that data is humanly a very, very challenging task. So that is where AI plays a big role. Of course, in communication, navigation, auto landing, AI is going to be a game changer because the real-time situations, it can be adapted for auto landing especially. MUMT and tactical decision making, that I'll come to that. Predictive maintenance of air assets, as AVM George Thomas brought out. This predictive maintenance is also one area where HAL is working in a big way. AI-empowered avionics basically we are in future will be using for flight path control, sensors management, because the number of sensors are increasing, the data from the sensors are increasing. So sensor management, we will use AI. Weapon delivery, we could use. Tactical maneuvering in hostile environment especially, AI will be a big help, and AI will play a big role in tactical decision making. AI will also play a big role in autonomous landing. Today, it's all as per planned waypoints. You come and land on a planned runway. Tomorrow, when AI is there, you could make a decision based on whatever the runway condition, real-time conditions of the weather, the runway conditions, etc. As he brought out, the rapid database access, organizing of information, and performance of high-volume procedural functions, AI will definitely ease out and will make it very, very quick. AI will also help in scanning, viewing, organizing, targeting, ISR, sensor input as navigation information, radar warning information, images or video. This is an AI-enabled MUMT concept which we are working on, called the Combat Air Teaming System. There is a mothership. If you see, there is a mothership, there are unmanned wingmen, and there are swarming drones. All this we are working, and Mr. Samir Joshi here is also one of the partners with us in this program. Second topic, what I would cover is the complex battlefield operation. In a complex battlefield operation, what we need is a multi-role fighter aircraft of advanced battlefield operations which can have strategic as well as tactical suppression of the enemy air defense or the destruction of enemy air defense, offensive and defensive counter-air operations, strategic attack as well as interdiction, electronic attack, close air support, intelligence, surveillance, and reconnaissance. The third topic is enhanced avionics and mission sensors. Today, we have synthetic vision, enhanced vision, we have combined vision system, we have what is called the touchscreen and LAD display systems in the cockpit. All those buttons and things like that have gone. Touchscreen is there, the pilot can configure whatever he wants and wherever he wants. We have low-profile HUDs, which are very, very nice to view through and doesn't obstruct any view. And then advanced mission sensors like the ISA radar, the EW suite, and their combination. Sensor fusion. As we said, there are dominant situational awareness through synergistic integration of information is what is meant by sensor fusion. Sensor management, fusion, or advanced sensors, radar, EW suite, IFF, so name it. So many sensors are there giving similar information which you need to interpret and make it into one item which the pilot can see. If you give all the sensor inputs at a time to the pilot, it is so confusing. So you fuse all those inputs, take the correct thing, correct it, and provide it to the pilot. Single fused view of the entire battlefield, a net-centric operation or a common operating picture for everybody who is in the airspace, who in our team, who needs to attack. The wearable cockpit, it is a very interesting concept. This is in the 6th generation aircraft what is planned by BAE Systems. The wearable cockpit is nothing but all conventional instruments are replaced with AR and VR systems projected directly inside the visor of the pilot's helmet. This uses artificial intelligence as well as eye tracking technology to allow pilots to control their aircraft by simply looking and gesturing. Fewer physical readouts, buttons, controls offer these following advantages. It is less material, less weight, reduced cost, easy maintenance, improved situational awareness, quick reconfigurations by tweaking the software, but reduced pilot workload, and finally, the day will come when the system will infer what the pilot's goals are and use intelligent systems to support the task and reduce the pilot's workload. The sixth topic is the directed energy weapons. Directed energy weapons are beams of concentrated electronic magnetic energy. It travels at the speed of light, leads to structural disintegration of target and causes its destruction by creating uneven heat stresses. DEWs can be broadly classified into high energy lasers or high power microwaves. Directed energy weapons have the speed of light. They are invisible and silent. They are not affected by gravity like other weapons. They have operational ranges larger than conventional weapons. They are easy to defuse or destroy missiles. Simplified tracking and beam pointing. Area coverage can be for multiple targets, and it's very cost effective. Only source of energy is required. And as of now, it's yet to be proven. We can say there will be minimum collateral damage because the energy weapon can be correctly pointed. The next type of weapons is the hypersonic weapons. Hypersonic weapons, as you all know, are missiles that can travel at Mach 5 or higher, which makes them very difficult to defend against or intercept. Two distinct technologies of hypersonic weapons are currently under development in the country, not by HAL but DRDO. Hypersonic glide vehicles, which are under development and which will be used ultimately to power the BrahMos missiles. The second is the hypersonic cruise missile, air-breathing scramjet missiles. This is the long-range land attack cruise missile, which is an upgrade of the Nirbhay missile developed by DRDO. Similarly, Shaurya missile, a hypersonic surface-to-surface missile, is also under development by DRDO. The next topic is the self-healing structures. Self-healing structures generally have smart materials that can auto-repair the damage, leading to longer lifetime and reduction of inefficiency caused by any degradation and material failure. Traditional repairs are generally expensive. Implement and to design, implement, certify, and monitor. Whereas self-healing provides early means of detection of the damage, is similar to modeling and mimicking of human body. See, everything comes from human body. The human body, when you have a wound, it heals by itself. So that is the idea which threw up this self-healing structures. This is similar to any living organism which can have the ability to self-heal. It has, if you see this picture, there is a smart material in between which will, if there is a crack, it will heal itself and that the structure remains intact. Next comes the nanomaterials, stealth and camouflage. There are two methods to obtain the stealth. One is the airplane shaping to reflect radar signals away from the radar equipment. The second is airplane can be covered in materials which can absorb the radar energy. Conventional camouflage by shaping are only successful at particular range of the spectrum. It's not over the entire range. Recently, there are developments happening in metamaterials which could be a possible solution to this problem. Nanotechnology and nanomaterial are promising approaches for the development of camouflage and stealth technologies. They are usually utilized as radar-absorbing materials, which again, a huge amount of research is going on in the country for radar-absorbing materials as coatings and structures. Other areas of ongoing research are the autonomous weapon systems. This we have to definitely take with a pinch of salt, whether we will be able to do it. Any weapon system, if you say with autonomy, that is a weapon system which can select the target, which can identify, track, and attack, that is use force against the target, damage or destroy targets without human intervention. This, yes, definitely, if it can be done, It will give increased precision, accuracy, faster reaction times. Okay, level of automation is increasing in the weapons, providing autonomy for selected critical functions, but full autonomy is yet to come. Autonomous, there are some certain emerging technologies, sensor-fused weapons, machine learning technology, AI for the autonomous weapons, all that. But as AVM George Thomas brought out, there are a lot of risks and open questions. The first is, of course, the increased complexity, loss of predictability and reliability, risk of collateral damage, legal and ethical implications, which are the biggest factor. And we need to take a great caution in development. Fully autonomous, therefore, is still a challenge. Last, I would summarize like this. Air power is a psychological weapon. And everybody, other than short-sighted soldiers who are too battlefield-minded, underrate the importance of psychological factor in a war. It is psychological factors that win a war more than all the other power. Thank you.
Thank you, sir. Thank you for elaborating on a few critical autonomous technologies aspects ranging from material to weapon systems. And also thank you for showcasing HAL's capabilities to progress on development and adoption of autonomous technologies. Thank you very much, sir. Moving forward, now let us get viewpoints from Mr. Shamir Joshi. I would like to brief his profile to the group. Sir is an ex-Indian Air Force fighter pilot with over 5,000 hours in aviation. Post-retirement from IAF, Samir has worked as an entrepreneur while being a founding member at Team Indus, India's entry into the Google Lunar X Prize Challenge, which was an attempt from private players across the world to design and develop a mission to soft land a robotic craft on the surface of the moon. He is currently the CEO at New Space Research Technologies Private Limited. He has been involved with the Indian MOD's IDEX initiative towards R&D of two cutting-edge air-launched drone programs. He is also an avid aerospace defense analyst and writer whose analysis of the Syrian air war won the Best Military Aviation Submission at the Paris Air Show in 2017. Sir, I would request you to share about the niche capabilities developed in the field of autonomous systems, collaborations, technologies demonstrated, and those technologies being worked upon, and what are the challenges and opportunities for MMSMEs in the sector. Sir, please.
CMD, sir. My esteemed panelists, ladies and gentlemen, it's a real pleasure to be part of this very progressive discussion. We have had a lot of these discussions in the flight ops and ARDC back in HAL, where Krishna sir has taken us a lot of time to task why this, why that. So before I move on to the larger perspective, I must compliment Air Vice Marshal Thomas and Mr. Krishna Kumar to laying down the paradigm quite nicely. We are aware now what is the need, what is air dominance, what is air superiority, how these various applications work together, and also what are the fundamental requirements to achieve the various aspects and the various technologies required, which will give us the command of the skies in the coming decades. Now, I will largely focus on what we do as a UAV company and what we are doing to supplement capability towards a teaming with manned platforms, which is also something which will be very much applicable in the days ahead. Another pertinent point I'd like to make is that, operationally, the Indian Air Force is already down to a number of squadrons which are below the overall requirement. And, it may not be possible, even if we look through that, we will never get back that same squadron strength what we aspire for. It does make sense to start exploring the possibility of getting in platforms which are robotic in natures at about a far lower cost to supplement the manned platforms of the Indian Air Force And not only, even if they are, are able to supplement and complement certain mission tasks in surveillance, in kinetic, non-kinetic ways, at the same time, other missions like decoys. So it will hugely increase the capability, the mission orientation, and the effectiveness, the way that the Air Force functions. And this is the context which I would like to start my talk with. I will also focus on the aspects of man-on-man teaming as we go ahead. So first is, beyond air dominance, I will cover a bit more on the environment we operate in. Why and how this is applicable. Largely the airspace in the days ahead. And this is very pertinent as, HAL being the designer of fundamentally aircraft. We have to make aircraft which survive in contested airspace. Now, what is that contested airspace? It is basically a series of overlapping capabilities on air, land, sea, electronic warfare, cyber, as well as space. Largely, the only aim is to impose maximum attrition on the adversary's offensive and defensive capabilities. Now, we have to understand the long-term advantage which air superiority or the numbers can give or have enjoyed in a permissive environment is no more applicable. This is very, very visible in the way, we see the Russian Air Force struggling back in Ukraine. A series of overlapping layered defenses have been put in place, and it has made life, and Russian Air Force is suffering a lot. Fundamentally, we have to understand that if you are ready to take the attrition, which no Air Force will be, given the high costs, this is only going to degrade the mission orientation and the capability, operational capability of any Air Force which when strikes through a layered air defense. These series of capabilities, through all domains integrated together, are called anti-access area denial. And this is what is largely going to dictate a lot of efforts towards future combat aircraft, manned or unmanned development in the days ahead. So one more thing, anti-access area denial. These two terms are very critical because to understand, so when these layers are put in place, anti-access basically means you degrade the capability of an enemy to come towards you. Now, obviously, Air Force, with its primary task, not only is in the defensive component, it also has the offensive capability to go inside the enemy territory and stop their strike vectors or their own air defense vectors to even come towards the vectors. So this is called offensive counter-air. And this is largely something which is very important when you supplement with long-range surface-to-air missile capabilities. So this is anti-access. Now, area denial is once the enemy is within your force. Let's say the strike vectors, the enemy strike vectors are within your force. How do you reduce their maneuverability? How do you degrade their capability? So now, this is the philosophy which is unfolding beautifully, and all followers of air campaign in Ukraine will be, seeing this implementation taking place. This is the paradigm where the air dominance or the local air superiority or perceived air superiority is going to take place. And largely what AVM Thomas rightly covered, the US has officially acknowledged, it cannot dominate a peer state or a near peer state capability anymore. And this is a paradigm which all air forces across the world, given the proliferation of surface-to-air missiles and advanced air combat platforms, will largely face. So, what is the capability? How do you counter this? There are two approaches, outside in and inside out. Largely, one approach is to unlock it layer by layer. And the second is, you just keep going and take on attrition and keep going forward. This is more akin to what the Russians have done. They took Ukraine for granted, and that is where they've suffered massive attrition. Had you gone layer by layer or in otherwise, you would have possibly been better. So we see that in the days ahead, given the nature and the flow of the warfare, drones will play a huge, huge role. And this is where the complementary roles of drones towards the man platform start. Robots are the future warriors, largely because of two facets. One is autonomy and one is AI. Now, autonomy helps the military extend its reach over the battlefield or in terms of endurance or range to a great extent. Robots which don't have any human on board can loiter or float over an area for a very long time. And these certain limitations are something which can be expanded upon in any aircraft design which is robotic in nature. The second aspect is AI. AI makes those robots very, very potent and very creative missions. I mean, I'm not going to go in the issues of the ethics of it. These are something for the larger higher call to be taken by the organization. However, there is a capability available, and level of interoperability 4 to 5 will be seen by the end of this decade in all platforms which are visible. And when you combine both these things together, what you do is you provide greater access in face of increased threat levels, at the same time penetration of well-defended airspace. Now, another beautiful aspect which is emerging is how do you, kind of control these things together. So that is where software, which what AVM Thomas was also mentioning about through the UDAN, is where they're focusing. You have to create that AI which can think like a fighter pilot or any kind of pilot, anything which flies. If we can replicate strike packages of manned airplane, through robotic platforms, and they can team up with the manned elements, this is something as layers which can take a lot of saturation, as well as saturate area targets or specific clinical targets. This is the key towards success of any initiative or strike vector going forward towards counter air. So software is the key for these cyber physical systems going ahead. Gentlemen, this slide covers the gist of it. Largely till about 2020, everybody was focusing on making intelligent machines. We have understood the definitions of autonomy versus automated systems. So largely focus from 2020 to 2025 is going to be on systems which learn, but largely limited to machine learning. They are not that classical AI which go into reinforcement learning and behavior trees. Post 2025, we see the advent of robotic swarms and man-and-man teamed capable air vehicles which are going to be there. Now, covering a bit more than what Krishna sir was saying and AVM Thomas has said, what is the difference between reinforcement learning and anything which is explainable AI? Reinforcement learning is, we have done a program with the Air Force, it's called the ACID, Air Combat Intelligence Development, where we teamed, two fighter pilots trained the AI to fight one versus one combat. Now the AI learned from the behavior of the fighter pilots, how they interacted. Now, after a while, the AI started to learn things. I mean, you take billions of run for the AI to be trained. DARPA has a program also towards the same, which was implemented last year in August. What is important to understand is, whatever you train the AI, but you still don't know how she will react. You don't have control over that AI on what it learns and how it will further react. You are leaving it totally. So this is called unexplained or unexplainable AI. And this is the facet of reinforcement learning, behavior learning. Very, very applicable in situations like one versus one, where you have to instantaneously take decisions, but may not be the right way for a group combat where it is a set piece task going forward. You have certain behavior which you want. So you mix it up with something called behavior trees. If there are a large number of platforms going together, these platforms know what are their parameterized behavior. Let's say it detects a target at 160 kilometers at a certain clock code, and it is confirmed through AI that it is an enemy vector. It starts to maneuver with the classic tactical tree which the Air Force deploys. That is behavior tree. Had it been given to the reinforcement learning, it may have reacted in a totally different manner. And this is where BVR combat from within visual range combat will be dictated more by set piece parameters through explainable AI, through something which the Air Force or anybody, any user can control. And this is the big differentiation when we say AI is not there yet. And that is why all aspect AI is something which is about at least 10 years away. And even after that, will we have the trust? And the ethics aspects will always be there for us to all to ponder over. Sorry. I'm sorry. Just. Iska back button nahi chalta. Yeah, just go back to the same slide. Sorry, gentlemen. This is the last slide. You escape and come down to the third slide. Just go back. Back, back, back. Yeah, this one. Then, of course, once we do this, by 2030s, series of air forces across the world will have platforms which will be robotic in nature, which will be flying along with the manned platforms. And these we call loyal wingmen. We can call, anything what you want to call, but largely they're going to be there. Remember, one key thing is the pilot in the cockpit is still doing his core job. He is not capable of distracting himself to control robots flying along with him. So the key lies in commanding them rather than controlling them. Your algorithms towards man-on-man teaming should just be precise to give a certain command, and thereafter that agent, that AI agent or robotic agent should do a task and only disturb you if there is a change from the parameters which have been dictated to him. And that is where, again, a mix of autonomy and AI is going to work going forward. Right. So the future of contested battlefields will combine distributed aviation with distributed competition. We'll talk more on that. But what is very important is collaborative autonomy. You know, when we dabble into this, again, as aircraft designers, it's very important for us to understand, even if we want to do a limited, capability where you have optionally manned platforms, where the pilot is inside and let the machine fly with the pilot inside. So there also you need to understand this collaborative autonomy. 3 basic behaviors emerge. Let's say the robots are flying with you. The first behavior is flocking. This is what fighter pilots do. When they go in a group, they flock amongst each other with varied command. Either it's a pre-brief task, or they go and extend their area of operations. So this is the behavior also of birds, which you go fly together. The second is unmanned wingmen. Unmanned wingmen, as I explained, very clearly something which goes a large number or a single unit with you, which needs to be commanded rather than controlled. That means there is a software which is residual on both the platforms, and this talks to each other, and this is fundamentally going to do 99% of the task, and the human is doing that 1% of the task. But it is still, the task is controlled by the human, and he is kind of commanding the platform to do a certain execution. And the last is, of course, swarming. Swarming, very fresh topic, a lot of work happening in the R&D domain all across the world. Now, what is swarming? Swarming is the behavior of platforms which is totally based on algorithms with zero input from the human. Now, this is what differentiates swarming from unmanned wingman behavior or the flocking. That means they are mimicking a biological element. It may be based, like we have built up swarms which is based on the behavior of bees. So we call it the ABC protocols. Now, similarly, all across the world, similar efforts are taking place. So in terms of collaborative autonomy, these 3 are the fundamental behaviors of any robot which flies with a machine or which is actually being controlled from the ground or the air. Then we have the paradigm of the man-and-man teaming. I mean, we have heard this term. Sir, both the gentlemen have defined it very nicely. It combines the strength of manned platforms which are supported by unmanned units to increase the situational awareness. And this is very, very important. When you increase the situational awareness, the mission effectiveness increases. And this is around which the MUMT protocols need to focus. And if you are not able to do this, you burden the task of the pilot, you are failing in this task. And that is where things, they start to go bad. Very important, this allows the armed forces to conduct kinetic and combat support and ISR missions in contested airspace. Okay. We talked about reducing the overall OODA loop. When robots are there, when AI is involved, autonomy is involved, decisions happen very fast. So what are the various offshoots of OODA, reduction of the OODA loop with MUMT? This is manifested through various kinds of platform. On the left side, if you see, these are the various platforms which can utilize this. Now again, something which is very will be part of the warfare in the next coming couple of decades and beyond evolution. So first is, of course, the unmanned wingman. Then you have robotic swarms. Then you have remote carriers. Now, remote carriers it's carrying something, it is released, and thereafter it does a certain class of maneuvering for execution of the task. It may be releasing further munition or drones, or it may be even going a standoff. It may have a standoff behavior, going forward. Then, of course, you have air-launched drones. A lot of work is happening on this side. The US is working on drones launched from F-15s, likely to proliferate amongst other fleets. And, of course, optionally manned platforms. AMCA is gunning to be one optionally manned platform. We already have the FCAS program of the Tempest, which is another optionally manned platform. So that means you design something, you send a pilot, you don't send a pilot, depends on what kind of mission grading you see or you deem fit. Again, this requires a very high interoperability between autonomy and the AI aspects. This is the future, ladies and gentlemen. Now, what is there in terms of technologies? On the right side, autonomy, of course. What is the level of autonomy desired? Can we execute autonomy? Just by writing autonomy, it doesn't happen like this. You have to define it. I want to make one thing very clear. I discussed that in the previous talk also. Mostly designers, when they start to design, they are not taking into account the concept of operations. Now the dilemma for the designer is, how do I design something which is to be employed 10 years down the line? So what is the ConOps? Because the engineering for tomorrow's weapons has to come out from the ConOps. Not that you make something and then you ask the end user, how do you want to use it? It will just not be, given the nature and proliferation and the faster iteration of product development all across, it is just not going to, actually give you the deep satisfaction of making a product. So this is again, what is the level of interoperability, LOI 5, 4, largely 4 and 5 is the desirable element when you talk of unmanned wingmen. Second, of course, now when we have robots with you, depends on you, you want to get them back, or they may have warheads which they can go and strike. So these are attritable and expendable platforms. You need to have a beautiful and a very advanced communication network. This is the backbone of any operations of large-scale man-and-man teaming. If they cannot communicate, you're out of touch, there you go. So the mesh networks have to be very advanced. You have to have frequency hopping. You need to have spread spectrum. You need to decide what is the spectrum. One of the major dilemma, again, as designers, Thomas especially, so when we ask for frequencies, there are only those limited frequencies. Now, the problem is, they may not be that optimal frequency of operations. So we need to find a way that how during the ops, we get down to actually that spectrum which is actually desirable. And especially when a lot of the backbone is going to be communication, this is a very desirable facet. Of course, sensor fusion, KK sir has covered, electronic warfare. Something different is combat cloud. When you have a large number of robotic platforms, a lot of decisions are taking place. Edge computing, huge levels of teraflops of data is being processed. You are not going to process it on a machine which can carry only limited payloads. So you may have a specialist machine which has very advanced computing requirements. Let's say it's fusing all data. Everybody's capturing certain data. It's fusing and running the AI algorithms on that particular machine. So this is something, just one of the features of a combat cloud. So you may have certain features of the cloud which is a localized cloud. Let's say you have a Air Force task force, a man-on-man teaming task force which is 400 kilometers beyond your borders. There are fat chances that you may not have communication link with them at all, the way that enemy is perceived to be. How do you operate? So this is where it actually goes into this. And of course, cyber attack and defense. Okay. KK sir touched upon it. I'll talk a little bit more. HAL has taken a very, very, futuristic effort called the combat air teaming system. Now, this has been about 3 years in the making. I've been privileged to be part of it. And what I can tell is that this particular effort is at par with similar efforts happening all across the world. This also necessitates the fact that it recognizes the fact that, unmanned platforms have to operate along with manned elements. And not only that, it has to have enough firepower as well as a technological edge to operate as a systems of system. And this is where the CATS, which is a Marquee program which HAL is supporting and which the Air Force is examining very seriously, is going to proliferate in the days ahead. Of course, it has various segments. The core around it is this is about the unmanned wingman. And this is being controlled by the LCA agent. Then you have a high altitude pseudo satellite, a high flying solar powered satellite. You have drones which are air launched and standoff cruise missile. I explained this a bit more with this graphic. Largely, what is the need? The need is to screen the fighter aircraft. When you go ahead, there is a screen of these robotic platforms which is ahead of you. Now, these drones, the robotic platforms, which may be the unmanned wingman, it will carry a higher payload. It may be ISR. It may be electromagnetic attack. It may be kinetic attack. And also these little, small swarms of drones which are floating around with various class of payloads. The idea is to confuse and degrade the enemy's warfighting capability, his layered kind of defense. Let this layer punish him if he's, shying off from engaging them, or kind of take most of the brunt of the attack, which is, there for the manned element. Remember, let's say you degrade the capability of the enemy to even for 1 to 2 hours to not effectively fight back. The Air Force can push a large number of different packages in all domain kind of attack. So this is the power of such a capability which in the days ahead. Next slide, Karna. On the finishing note, I am also showcasing a slide. This is something we are working in my company, New Space Research and Technologies. We call it the RNGMT, the Next Generation Missions and Technology Vision. The idea is to overlap product development with partners like HAL as well as Air Force. So if you see from the bottom right, again, this is what we plan to do towards penetration of contested airspace. Autonomous, AI, future-looking, all through MUMTI protocols, everything architectured with mesh networking and network-centric warfare. So on the bottom right are swarm drones. This is something which is we are supplying to the Army. We were also winner of the Air Force's swarm drone competition, the Meher Baba competition, basis this. These drones can affect or influence till about 50 kilometers through range and a one-way range of about 120, 130 kilometers. Then we have a IDEX program with the Air Force as well as a program with the HAL called the Alpha. This is an air-launched drone. The idea is to go further, about 300 to 400 kilometers. And another platform with low RCS is being studied by the Air Force. And this is something, as people have already identified, low RCS technology is one of the core elements to survive in contested airspace. Of course, on top, we have the HAPS platform, the solar-powered UAV, one of the most technically challenged design. This is something, a long gestation period. Again, we are undertaking with the HAL. But largely, gentlemen, I'll end here by saying that the future is not going to be a single platform. It is going to be a combination of various technologies, various platforms, and most important, a very creative concept of operation. And this is where the larger engagement between the end user and the engineers and the designers needs to take place more and to largely define what lies in the future for a well-developed product development initiative. Thank you.
Thank you, sir. Thank you for sharing a very comprehensive insights on anti-access, offensive capabilities, and also outside in and out, inside-out approach, and various key success factors. And also you have highlighted on the future warfare, manned and unmanned teaming operations, and the concept of operations to be considered while designing the product and systems. Thank you very much. Let us now move forward. IIT Kanpur has taken up various research projects in the emerging fields. Today we have with us Professor Depobam Das from the Department of Aerospace Engineering, IIT Kanpur. Sir is a joint professor of the Department of Aerospace Engineering and Sustainable Engineering, IIT Kanpur, India. He obtained a PhD degree from Indian Institute of Science, Bangalore. He has worked as a senior research scientist at laboratory at National University of Singapore, postdoctoral research fellow at Florida State University, and as an assistant professor in the Department of Mechanical Engineering, IIT Guwahati. His research interest is in the flapping wing UAVs and underwater vehicles, supersonic flows, wind and hydro turbine development, aerocaustics, and instability and transition. He received Excellence in Aerospace Education Award for 2015 from the Aeronautical Society of India and the Devang Mehta National Education Awards in the subcategory Educational Leadership Award. The flapping wing UAV developed in his laboratory as the highest endurance in the world. Professor, please share your insights on the technological developments and research projects going on in various R&D organizations and academic laboratories in the field, and what are the technologies in IIT Kanpur being incubated, emerging fields of research and roadmap for converting R&D concepts into application. So please.
For air dominance for our country. And if you see as I go through, so far you have seen operations and real world, and now I'm going to talk about probably one aspect of that is the futuristic autonomous technologies. That a few things that we will be talking about, mostly the unmanned systems and some little bit about the weapons also. So I have several collaborators, and usually in academics when we use others' work, it is our practice to acknowledge all, and you can see their names in the below. So Next slide. Yeah. So I'll briefly talk about an introduction and the nomenclature that we are familiar with, but we are going to talk about some of the new things that you will observe in near future probably as a platform as an autonomous system. That means the futuristic drone research development. And I'm going to talk briefly about, with some examples about in academic institute, what is going on. Few examples I am going to give, particularly worldwide, and that will give you the flavor of what goes on. It is not the entire all that I can summarize in this small time. And obviously then I'm going to focus more on futuristic drone development work that is, sorry, that is going on in IIT Kanpur. Some of the potential military and civil use, and finally I'll conclude. Can I have the next slide? Yeah. So where are in the new era of this technology of air dominance? So technology for air dominance, why do we need this? So because my slide is heavy in images, so I cannot play in slide mode, so I have to play it in this mode, so I cannot go point by point. So drones are going to be a big name in the coming generations, and I think drones are, as you've seen that from the distinguished speaker's speech, that drones are going to be a layer for your air defense systems or air dominance. So drone means that drone is something which makes continuous sound. And this word came because the drones makes a honeybee kind of sound. And sorry. So this drone is not something that it is a very recent thing. Drone has originated before even World War II. In 1931 to 35, at that time, US, UK, they wanted to moving target. Targeting a moving target was a challenge at that time. So a little bit with this historical perspective, I can tell you that how do we get a moving target? So you don't want a moving target. At that time, moving targets were all manned targets. So the requirement of drone came at that time, and that is the time first drones were developed. And maybe now 100 years after or 90 years after that, we are back into these drones. Even if you see, next slide please. So drones have different types, as I listed. I will come to those later. Even in World War II, drones were used by Germans, and that created a lot of havoc, particularly in British areas. So it's a winged bomb, nothing else. So that this winged bomb, that V1 or Vengeance 1, was used very precisely. They could calculate the explosives. It is a rocket propulsion kind of system. And then it guided and hit the target in a very precise way. So that is why right now if you see that the weapons that we are talking about, some of these weapons will be the miniature versions of this or some kind of thing, some more advanced versions of this. Next slide, please. Yeah, so drone applications, as I probably can skip these slides. The drone applications has many areas that we all know. And one of the major applications is the recon. Then you have short duration service, long duration service, as we have already heard from the previous speeches. So drone can work as a platform. As you have seen in a swarm platform, they can be very useful. And they can have many other civilian applications, as you see that what has been listed in the oil and gas, these things. So next. So here I am going to talk about very elementary things of drones, but I am going to bring out some new drones. And what is the problem? That is what I have highlighted. And one key features of the fixed-wing drone that you have seen that even in Afghanistan recently, you can do a very precise strike using the fixed-wing drones. And the drawbacks, obviously, that it cannot hover like a rotary wing drone or the quadcopter that you see. That is the. And the dynamic recon, because it is a high-speed vehicle, so dynamic recon is not. So if you have a ground dynamic moving target, so it is very difficult to pinpoint to identify that. The next. So multi-rotor drones you are seeing everywhere, from the marriage parties to agriculture to every place. But the biggest drawback of that, it is actually the least efficient. If you see that efficiency it is poorest. So it actually the battery guzzler, if you think in terms of the design, because you have multi high-speed rotors instead of like single copter. This multi-rotor drones are actually, that's why they are very inefficient as far as power consumption is concerned. Next slide. Although they have a very, very utilities, and that's why you see that. Some of the hybrid VTOL drones we all have seen, and maybe we can move to the next slide. These are the future generation drone, futuristic drones that you will see now. You will see that amphibious drones which can fly, dive in water, and again it can come back. Okay, so right now if you see such projects are going on in the academic institutes, and in IIST Sipur, I know there is one project supported by DST in the similar area, where we are trying to develop a drone which can at least demonstrate a small-scale drone which can fly like a fixed wing, fold its wing, dive, and then again come back. And that is the kind of drone that you will see in future. The next slide. So kite stack drones. So this kite stack drone has a lot of potential for surveillance and recon. Kites are all we have used in the childhood. We have played with kites, but this has good potential because it will be tethered mostly. And if you want a fixed area surveillance, which is like city surveillance, city crowded area surveillance, if you want to do, such kites can be deployed there, which can be controlled. Obviously, it is not like a kite which is left free. So then you bring in autonomy in the kites, then the kites can be used as a drone, which you will see in future, which will not be disturbing the people with sound or any other thing, but you can do a survey very nicely. Next. So manned drone also will be, you will see, because that has medical use. You want somebody to take some from one parts to the hospital, nearby hospital quickly. This kind of manned drones can be used. We are talking about air taxis. Such things may come in future. And as I have seen that there is a lot of effort with the manned drones. And you all know that the biggest challenge with the manned drone, I think all drones, the biggest challenge is the battery. Unless we resolve the battery issues, these drones are not taking off to the level where we wanted to take it off. Engine drones, again the problem of pollution is going to come into picture when you make the engine drones, because pollution control will be one of the issue if you want in an urban operation. So some of the other academic institutes effort, I'm just going to briefly give few examples. Next slide. So this is in Naples, Department of Science and Technology, University of Naples. They have a balloon hybrid drone. So you can see that it can work like that kite, what I said. It can have a long monitoring purposes. It's similar to blimp or the aerostat that we are thinking of, but it is of a small scale. It can be located in a fixed location, or it can be given a small guidance also. Next. So this is what about the helicopter and quadcopter. If you see the robots, Japan is way ahead. And this Professor Nurami was a person who was leading when there was a Fukushima accident. They tried to send the drones and other things inside. And by the time he has developed this, some of the small drones and small unmanned vehicles. He has company also, and now he's, I think, retired from Chiba University, Japan, and he has his helicopters now inspect the high tension power lines in Japan. Okay, so one of the interesting thing that he showed that is in the last figure that you are seeing here, this one. So one of the problem of the drone is battery. So quickly changing the battery. This is a station where drone can come. This is a system, and then the battery can be just swapped, and then it drone can fly again. So this is what he showed in one of this conference of intelligent unmanned systems, which is held every year. So that is what where he had shown this. Next slide. This is well known of probably all of you who see and get fascinated with the drones and known with the Professor Vijay Kumar's work in Penn State and University of Pennsylvania, sorry. And he has demonstrated many, many things, like even a construction of a building using these drones. Swarm drones, software and platform, and then also he has talked about the drones that can change their shape and maneuver differently. Okay, so his work is a very pioneering work as far as swarm technology is concerned. You also see that ETH Zurich has some activity. I have tried to give few examples of these things. So where you try to do the precision control without any human risks, and these drones can do some aggressive maneuvers also. Now I come to the IIT Kanpur Futuristic Drone Research and Development, and we have also some interesting thing which is different from what these others are doing. So next slide. So at least in the single copter, the Professor C. Venkatesan, who is right now in IIT Jodhpur, and he is actually the helicopter person in academia before his retirement. Even now he is in the IIT system. So he developed a helicopter, unmanned helicopter, and he has his own algorithm to fly it in a GPS-free environment. So GPS-free autopilot he developed at that time. We also have now different other drones that our group is working, and one of this is this flapping wing UAV, which will look like a bird, and I will show shortly, where this IST Sipur, one of my students, has become faculty, and he is now also involved in that. And we also work on some of the fixed-wing unmanned drones, fixed-wing drones, which is to apply in Mars. So it has, again, same challenge as HAPS, because HAP is in high altitude, you have a very low density. So here also you will find in the Mars the density is very low, although gravity is low, but density is very, very low. And there are a lot of challenges. So you get a high Mach number flow in this even drones, which is a challenge. Although the Reynolds number is very low, that means flow velocity is very low. Next. So in the Mars program, which we have an Indo-Russian project in which IIT Kharagpur and IIT Kanpur and then the Russian Aviation Institute Moscow is involved. So we are trying to design a box wing type of drone with an aerofoil which will be very low Reynolds number aerofoil. And we are addressing this right now computational wise, and Russia, they have a low density tunnel and we are going to test it. And next. And then flapping wing UAV. This flapping wing UAV is the forte in which I am working for last several years. And here, already one MIT professor has shown that flapping wing UAV is the most efficient among all the UAVs. Take it fixed wing, rotary wing, flapping wing will be the most efficient. The simple reason is you don't have a very high-speed rotating propeller. There is no high-speed rotating propeller. You have just a single motor. If you can design properly, that will flap, gently flap the wing. The larger the flap is gentler, smaller the flap is faster. So if you see a mosquito will be flapping in kilohertz, whereas a eagle will be flapping in 1-2 hertz frequency. So that's why the flapping has a lot of potential. Some particular design like the one this is shown can hover also. And if right now we are also working on a Dragonfly project supported from DST, that where I believe that we can make a bigger Dragonfly because prehistoric evidences are there where you have the Dragonfly of about 2-meter wingspan. And Dragonfly is the most controllable, efficient flyer that we see from the natural design. I usually work on biomimetics, so mostly copy from nature. I am not copying from others, but I am copying from nature. But it is those designs we try to biomimic. And This dragonfly, when we developed, I will show, but I can show right now we have several birds like this thing. So here it is just a glimpse of the pictures of those birds. And these birds, when we started, a smaller one, 30 centimeter wingspan, which can fly for 10, 12 minutes with a small camera of 4 gram, that time available. Slowly we improved it to half an hour with a 1 meter wingspan, and currently we have a 1.8 meter wingspan. The yellow tip wall, that picture you are seeing, that can fly for 1 hour with 2000 milliampere hour batteries, in which with the same battery, if you fly for a quadcopter, it will fly only 20 minutes, if not hovering. If it is hovering, it will be even less. So this is what the kind of efficiency difference, if we are able to fly this or build this kind of platform, and this is going to give the advantage. So here I have two small videos, and to show the ability of this flapping wing. So maybe we can click in the first video. So this is what I said, that 1.8 meter wingspan. This thing, we have flown it we have a small airfield in IIT Kanpur. We are lucky in that sense. And when we flew, so if you see if it is far away, it is very difficult to identify it from the bird. So it will look like a bird, and you can camouflage them very easily. So that is the problem that last week only I went to BSF camp, and they are saying that drones, if we fly, enemies, they see, they get the sound and they shoot it. Okay, so we need something which can camouflage properly, and this has that camouflaging ability. So this platform, we are not able to mimic exactly what eagle does. We are mimicking the primary deformation of the wings. When it goes down, it has to deform in some way. When it come up, it has to deform in some way. And I can claim that our design is why it is working so well, is we have just one small motor of 40 gram, which is driving this 700 gram bird for 1 hour, because with those two batteries, because with one motor, rest of all this deformation, three-dimensional deformation, this we are able to achieve through the passive deformation. That means with the wing, whatever interaction, so we use the flexible material as the surface. This is the Jaideep Bhumik, who is now IIST faculty, who is working on that amphibious drone right now. And then the second video shows that now what is the ability where you can reach. This is obviously a small one. So you can see that you can actually make a platform which can just mimic fly like a bird. It can maneuver like a bird. So that is what I just wanted to show this small videos to this new platform. Problem with this platform, how do you make autonomous? Today you make a quadcopter, hexacopter, octacopter, fixed wing vehicle, you will get n number of autopilots available in the nets, and you can download and you can develop, and some of your HL trainees who came there, they made I'll show that, they made a quadcopter, and they autopiloted it, and then they attached with it a drone capture net, which ejection mechanism they designed, which I said they can patent if it is, they do a patent search, and if it is not available. So autopilot for any standard platform is very easy, but autopilot for such thing is not so easy, and where I think again the AI help we am taking from Professor Indranil Saha from Computer Science Department of IIT, and again, it is like we don't know about, we are not going from the control surfaces like the tail, how much we should deflect, how much we should move up and down and all these things directly, and then based on that we are not making a flight dynamic model and going to make it autonomous like the others. We are because all those things will require a lot of time and a lot of effort, data and all these things, and it is very difficult because a bird, same night angle, when it flies at 4 meters per second, it will be at one angle. If it is flied at 8 meters per second, it will be at another incident angle. So those data will be so much that, because all other research has gone over the last 100 years, and they will not able to catch up with those data. And I think AI is the solution, and that's what we are planning. Next slide. So this AI will be something like a kid's learning how to walk. So a kids learn how to walk, they fall down, and then they correct. So this autopilot AI is actually same as this what we are doing in this. From mistakes, when the kid touches the hot cup of their parents and then get the heat, then they are careful. Then they learn that they don't have to touch. So this is how I think this AI thing that we'll look for. This AI platform which will like AI-based platform which will make this bird autonomous. And once it is autonomous, it will have very good use in these systems. We also are continuously working on improving this performance of this bird, because this bird flies at 25 kilometers per hour. So we are trying to increase its speed by incorporating new mechanisms in it. We are also, but all passive with the same single motor. And also we are trying to do more mimicking like birds. So birds fold their wing when they go up, because upstroke is not a desirable stroke. So they fold their wing. Insects, they can actually flip their wing. So that is what bird folding wing we are going to do. You can skip this slide. I have already talked about the AI. So now comes about the precise arms. So this I am working with Professor Sandeep Saha of IIT Kharagpur, who is also my collaborator in Indo-Russian project of this fixed wing aircraft. So we think that if we, like a dart, when you think, you can actually precisely control and hit the target. So that bullseye hitting, same idea we want to incorporate, autonomy we want to incorporate in that. But for that, we need to understand how it behaves, how it actually works. So next slide. So you can see that the fluid dynamic phenomena is quite nonlinear and difficult. So that's why we need to understand this, and then we are planning to work towards this. This is the work done with the HAL team. Recently, HAL trainees came to IIT Kanpur for the training, and we gave them 6 groups, 6 projects, and one of the projects they successfully demonstrated that this is what I was talking about, the build the quadcopter, 6 weeks program it is. In that 6 weeks, they have built the quadcopter, and they used 2, this is drone, basically the drone catcher, that is what we are talking about, and 2 mechanisms they made, and this one is particularly the net which can used successfully. And what I think we should be able to design a net in this case in a way that the net, if it is a cotton threaded net, it will come down, it will spread, but it cannot expand. But if we try to design and develop a polymer threaded net, as it comes down with the gravity, because of the force it will expand, then chances of capturing the other drone will be also increased. So we are going to work on towards those directions. This is not air autonomy so much. We have already built a prototype of this. This is a manta ray, again because of its nature of flapping. And go to the next slide and just play the video quickly. So you can see that again we are able to mimic the motion of the manta ray fins. Okay, so with the single motor. The other model is with the motor, which can be now tested in the underwater, which a MTech student has done this work. These are 2 MTech students' work, so we are not progressing in this. Another problem with the drone is the power. So can we do the power generation? The futuristic power generation effort. Particularly, we are concerned with the power with respect to the Mars rover and when we are talking about the Mars mission and all. Next. So we know that conventional power generation mechanisms are many. And go next slide. And we use the solar power generation quite like effectively in many of these applications, but uncertainty of this outer planet you don't know. So we are trying to build solar wind combine and some of that other modification in the rover itself, that the drive mechanism itself, instead of battery or motor power, you use the air-driven motor, and that can do this. So you need to, in that case, compress the air, but we have to see the efficiency of those. So working in those directions, solar-wind combination, as you see, and with that, next slide. Yeah, so you can see that there are other options, fuel cells and other option to have a long endurance, this thing, but these are the futuristic power generation. This is the last weapon that is, it's a camera, it's not a bomb. So this can be dropped. This we have already applied for the patent. This can be dropped from a drone. In a jungle area, you cannot see what is happening in the ground. So this camera can be dropped from, let's say, your helicopter or quadcopter or a manned vehicle or unmanned vehicle, or it can be catapulted and throw if the distance is small. And then it will catch using the mechanism of either bats. The catching mechanism is either bat, and I'm a Bengali and have done a lot of fishing in the young ages. So the fish hooks are very good to catch anything. And we have seen 99% time we are successful. We have designed a different kind of attach many fish hooks. And so it will catch the branch. And now there is a mechanism which will bring this camera down. And once it brings it down, then you can see nowadays the 360-degree cameras means you can see in front entire area you can see, and you can communicate that with the mobile. So that is what we have done next. So this is you can see one of the very advanced thing which came in the Nature journal, which is the best publications that you can get in this. This is the work from an Imperial College London. I don't know whether it will play the video or not. This video is, the drone is doing the additive manufacturing, that means 3D printing, okay? So it is available in YouTube and link is given, so you can see that it can do the first time, the drone can also do the additive. So this is a very precise control problem which also this kind of quadcopter can handle. So the quadcopters are maybe inefficient vehicle, but they can do a lot of things because they can be very stable platform, which others cannot be. Okay. So I think with this, next slide. Yeah. So I think I'll just skip this. I think I'll thank. Next slide. Thank you. Okay.
So thank you very much for sharing your research insights on futuristic drone projects, and also very interesting aspects, usage of drone in civil activities and various other things, the projects undertaken by IIT Kanpur. Thank you very much, sir. Now, due to paucity of time, I think we'll take some 2 or 3 questions.
Which is just a synthetic vision it's like our HMDS. On the visor, you have AR as well as VR, and it throws the entire cockpit symbology, all touch screens on the surface of the cockpit. So you don't have cockpit panels like olden days. You have things, and where you touch, you operate. That's the wearable cockpit.
Thank you very much, panelists, for a very insightful discussion. I'm Colonel Kevin D'Souza. I'm IDSA scholar, and I've researched the industry and transfer defense technology. I've been observing the last 5-6 years how the industry is moving, and comparing it with what we have in the US or Europe or wherever in the West. So it appears there's a very good combination of all of you here, because you've got all the tiers, right from applied research in IIT Kanpur to prototyping by new space and maybe HAL, and then finally, of course, the user, the Air Force. But there are some gaps here which I'm noticing. One is the fundamental research, where you need certain materials and certain inventions in certain phenomena, which is constantly coming out from those 200 universities in the US. They come out with something like 10,000 new discoveries and inventions, which is not happening in our universities in India in the fundamental research field. So obviously you are dependent on them, or it has to come from somewhere. The second thing is about the user. See, you're talking about capability, which the DRDO person has rightly said, that you have to define the capability. But the capability will also come when we understand the threat. So in the Ukraine-Russian war, we know that the threat is, for example, let's say a Russian SU, your fighter is coming, and you've got to down it. So you can work out a solution to down the aircraft. Or similarly, if you want to go and bomb a certain ammunition depot or something like that, there are many solutions to it. So one is like you send a long distance missile, or you send a small drone to go quietly across, in the, hugging the ground and so the threat, is it possible for the Air Force to define the threat that the Indian forces will face, and then allow the industry and the R&D and everyone to get into the act?
Thank you for that question. There is no easy answer. So the answer is yes and no, in the sense that the Air Force can define the threat. But in today's world, that definition will be only as old as the paper it's printed, and it will continue to change from day to day. So rather than define a threat in a set of boxes, absolute definition of threat, we look at emergent technologies, because we are aware that the thinking and the ConOps that we evolve is roughly similar to what is happening across. Bearing that in mind, we define a threat envelope, if you may, which covers certain key technologies, and we interface with both the public sector as well as the industry to try and identify use cases for which technologies have to be developed. Definition of threat, the way you're asking, is done internal to us purely from a tactical standpoint. But technological standpoint is what I'm describing. We give technology use cases and we try and get solutions for them.
I just add to that. Praveen Sahni has come out with a book called The Last War, and where he's come out with some very kind of radical understanding of how China will subdue India within a week or 10 days, because their technology is so far ahead. And he believes it's a reality, and maybe it is so, because that's what people are saying. So if we don't analyze that capability that the adversaries have, and then try to see how do we counter it, how is it going to happen? Just building up capability by ourselves is not going to help.
I think you, before I hand over to Samir, I think you do us a great disservice if you think that nobody's, your implication is that none of us are analyzing what is happening. And the second is that if we were capable of being run over in a week, I dare say we would have been by now. I'll leave it at that. Samir wants to take on something.
No, so Colonel, very pertinently, you're pointing the right things, but please do not assume that people are not doing it. A startup like ours, who has to survive and who is working on future tech, if we don't do this basic homework, we will never define products which we can convince the Air Force or a company like HAL to wet through and buy. So first is, absolutely right, you don't have control over the full flow of things. Largely, all I can say is that there is a good enough knowledge base on the threat levels, the technologies required to address that. Now the ConOps required is being addressed. Air Force is very actively looking at this. And if you take a look at the last 2 years, the number of RFPs and the programs and the projects, either through various mechanisms the government is coming out with, it gives a clear indication that they're being very ambitious targeting. Yes, you don't have the capability, but till the time we don't, rattle the nerve, it is just not going to, react back. So there is, we're not there yet, but we have definitely started to move. Praveen Sahni is pointing a lot of right things, but I'll say that some things are work in progress, and a couple of years back, or rather 5 years back, I'll say none of it was there. There was There was too much already on hand to kind of go through with the conventional and the old school, technology base, which everybody was busy with. But I think everybody, the end users, the academia, the industry, and PSUs and partners all across India, and the Indian aerospace defense ecosystem realizes that if they are not updated with the future tech and the use cases for that, they will never be able to build a product which not only can be sustained, but will not perform in the battlefield. And in the end, for people like us, there are no commercials. So this is where we all connect it all together. Thank you.
Thank you, sir. Thank you all the distinguished speakers for sharing your valuable insights and viewpoints on the topic. To express our reverence and gratitude, I request Director Operations, Sri E.P. Jaideva, to hand over a memento to all the speakers. I request Mr. Vinay to coordinate. Sir, please. Now I request the speakers to join for a photo.
To send that gift to them. No? Wonder कैसे भिजवाना है?